Can you see my PowerPoint slide on chapter 4 now?
Yes, sir.
All right. We were on chapter 4 discussing about chemical reactions. We talked about chemical reaction, types of chemical reaction based on how reaction take place and based on reactivity. And we also balanced the chemical equation, gone over how we change stoichiometric coefficient to balance chemical equation. Now today we're going to start with predicting ions, how ions will react in aqueous solution. Most of the chemical reactions are done in water. So water is an important solvent. So we will discuss about precipitation reactions, acid-base reaction, and gas formation reactions. Then we're going to move on to oxidation reduction reaction. And then talk about stoichiometry. Stoichiometry starts with getting a formula weight from the formula of a compound. We're going to see how we do that. And we're going to look into mole and mass calculation. So I'm going to probably cover up to 4.6, section 4.6 today. Then rest of the sections are going to be covered on Thursday. We go now balancing chemical equation. That's the last slide we did last class period. You change the stoichiometric coefficients. Change the numbers in front of chemicals. You put a 2 here. Then you put 8 here. And you have 10 hydrogens, 20 hydrogens. You put a 10 here. And 26 here. Then the equation is balanced. Not 26, 13. These are the numbers that balance the chemical equation. So you have to change the numbers and balance the number of carbon atoms, oxygen, hydrogen on reactant side and the product side. So we have this equation. To balance, you start with 3 here. Only set of numbers start with 3 is 1, the choice D. So this is 3. 3 times 4 is 12 hydrogens, 8 hydrogens there. To make it 12, you put a 2 and 12 hydrogen, 8 plus 4 is 12. So that's the correct answer for that. Respiration is glucose, burning glucose in oxygen to produce water and carbon dioxide. None of these reactions are respiration. This one doesn't produce carbon dioxide and water. Therefore, even though this has glucose, respiration is glucose converted to water and carbon dioxide, burning in oxygen. Therefore, you check the balance on this equation. is balanced. There were 6 carbon atoms, 6 carbon atoms. 12 hydrogens, 6 times 2 is 12. So the rest of the oxygen also balance. That's how you balance the chemical equation. Now we're going to go into how we do aqueous solution reactions. Reactions in aqueous solution, water solutions, using ionic compounds. Ionic compounds are also called salts. For example, salt is the name for sodium chloride. Sodium chloride is the ionic compound. But generally, salts are named salt is indicated for use for ionic compound. Ionic compound have cations and anions, positive and negative ions. When an ionic compound is dissolved in water, it breaks up their ions. Cations and anions separates out, dissolves in that. Sodium chloride is a solid. If you put that in water, that produces sodium ions and chloride ions. This aqueous means water surrounded by ions of sodium and chloride, surrounded by water molecules. Let me show you in the picture. Here we have a sodium chloride crystal. When you put that in water, it dissolves. Dissolves means goes into solution. These green balls are chloride ions. This purple ball, small purple ball, is sodium ions. Now, on the side, the sodium ions, a bigger picture showing how the sodium ions are surrounded by water molecules. The oxygen dipole, negative end, is facing the positive end of the sodium ion. On the chloride ion, positive end of the dipoles, water we talked about has positive end of the dipole on hydrogen atom. Therefore, it's a charge attraction between water molecules. These aqueous ions are called solvated, solvent surrounding, solvated ions. We said that about here, solvated ion, dissociated into solvated ion. Solvated ion means they are surrounded by water with positive ions attracted to oxygen atom of the water, negative ion attracted through the positive end of where the hydrogens are in water. Now the question is, if you prepare a water solution of a salt, ionic compound, and if you make two different solutions and mix, what takes place? This is on the top is sodium chloride. On the bottom is, before adding, is a clear solution of sodium chloride and silver nitrate. When you add sodium chloride, this precipitate is formed. Now, when you added two solutions of ionic compound, why you get a precipitate is when you add these combinations, sodium chloride ions, silver ions, they create two more new combinations, silver chloride and sodium nitrate in the solution. If one of them are insoluble, Insoluble means they're coming out of water if they're insoluble. Therefore, we have to find out which one is soluble, which one is insoluble. This is soluble. I'm going to show you how to predict that little later. Silver chloride is insoluble. Therefore, silver chloride comes out of the solution. That is called a precipitation reaction, precipitate form. So that's how you predict whether reaction takes place between two ionic compound solutions. If the combinations are, none of these combinations are insoluble, then there's no reaction. You have just ion solution in the water. To precipitate out, you have to have an insoluble salt. So the reaction between ions, if that takes place by producing insoluble salt, is called precipitation. I'm going to talk about the same two ionic compounds, salt solution. Ionic compounds are called salts. The first solution is silver nitrate. We already talked about it. That's the solvated ions of silver nitrate ion, sodium ion, and chloride ion. You can write a complete ionic equation by adding everything that you put in. You start with these two. When you put ions, these together, this is the combination. These four are written down here. And when you mix up, there's a possibility of silver chloride forming and sodium nitrate. Sodium nitrate is a soluble salt. Therefore, it is not a precipitate. Precipitate is shown as a solid. Therefore, complete ionic equation shows how the insoluble salt is produced. So there are ways to write down chemical equation between ionic water solution of ionic compound. Complete ionic equation is the total thing that takes place. A molecular equation is when you write a normal chemical equation. Molecular means ions are not shown. That's what happened. This is the silver nitrate with sodium chloride, produce silver chloride and sodium nitrate. This is soluble. This is soluble. This is not. Therefore, solid is formed. So chemical equation or molecular equation is the normal way of showing it. Complete ionic equation shows how the ions are reacting with each other. There's another way to show reactions between salt solution. This is the complete ionic equation, which I shown in the previous slide. If you look at this equation carefully, sodium ions, nitrate ion, sodium ions here. If you find both these on the reactant side and the product side, nothing happened to them. Therefore, there's no change in sodium ions and nitrate ions. They are called spectate ions. Spectate ions are not participating in the reaction. Therefore, net ionic equation is the one that when you remove sodium ion and nitrate ion. Left over is these three, silver chloride. Therefore, it shows what exactly precipitated now. This is another way of showing details of reaction, that ionic compound in water, how it takes place. The next ionic only show the ions that react. Once that react is silver ions and chloride ions to give silver chloride solid. Ions that do not participate in the reaction are called spectate ions. From the complete ionic equation, you remove the spectate ions, you get the net ionic equation. Sometimes they ask questions about this, which is the molecular equation, which is the complete ionic equation, net ionic equation for precipitation reaction. This idea is used in many chemical reactions. You will see it later. Now, let's see whether you can predict what aqueous solution of salts will react with each other to give a precipitation. Now, this question is about the spectate ions in precipitation reaction. A precipitation reaction takes place between copper 2 plus, chloride, potassium sulfide. All these two are soluble salt, copper chloride and copper sulfide. And copper sulfide is formed, potassium sulfide and copper chloride here. And potassium chloride is formed. Only combination that is soluble, insoluble, like silver chloride, is copper sulfide. If you look at this net ionic, complete ionic equation, chloride here, potassium here. Nothing happened to potassium and chloride ion. Therefore, they are the spectate ions. So question is, what are the correct set of spectate ions? It should be that one. Therefore, answer should be B. Now you should be able to look at a complete ionic equation and figure out what are the spectate ions. Answer is B. Which of the following is the true spectate ion? That's word problem. Spectate ions form solids. That's not true. Spectate ions remain in the solution. Spectate ions form gases. They are not gases, they are solid ions. That's not true. Gas is when, like carbon dioxide, sulfur dioxide, oxygen is produced. One spectate ion oxidizes the other spectate ion. We're going to talk about redox reaction, oxidation, reduction reaction. The precipitation reactions are not oxidation reduction reaction. Therefore, that statement is true. It will be clear after we do redox reaction. Spectate ions do not participate in a reaction. Normally, spectate ions are the ones that don't participate in the reaction, like in precipitation reaction we shown here. Answer is D. Now, we were talking about insoluble salt. How you know certain combination of ions, cations and anions are soluble or insoluble. We pointed that out at the first slide. There are solubility rules that indicate which salts are soluble, which salts are insoluble. There are solubility rules. First rule is most common rule. Group 1A and ammonium ion. Lithium, sodium, potassium, rubidium, cesium is group 1A cations. If a compound is, for example, sodium carbonate, regardless of what the anion is, if sodium is there, it's always a soluble salt. Same apply to lithium, potassium, rubidium, cesium, and ammonium ion. Any of these salts containing one of these cations are soluble. Therefore, sodium chloride is soluble. Anything with sodium is soluble. That's the one of the solubility rules. Also, anions, nitrate. If anions are one of these two, for example, anything with nitrate anion, acetate ion are soluble. Then the third rule is chloride, bromide, iodide, and sulfate. Sulfate is SO4. We have talked about it. Are generally soluble. Exception is four exceptions. Silver chloride, lead chloride, barium sulfate, lead sulfate. So if you look at chloride, bromide, iodide, sulfate, this basically applies to chlorides. All bromides are soluble, iodides are soluble, except chlorides, silver chloride and lead chloride. Sulfate, except barium sulfate and lead sulfate. So you have to remember these. The fourth solubility rule is carbonate, phosphate, sulfide, hydroxide are generally insoluble, just like chloride, bromide, iodide, and sulfate. Exception are hydroxide. So anything carbonate, any salt with an anion, carbonate anion, except these cations, except ones with these group 1A cations or ammonium ions are insoluble. Same apply to phosphate. Same apply to sulfide. Hydroxide are generally insoluble unless they are combination of lithium carbonate, sodium phosphate, any of these sulfide. This decide what carbonate, phosphate, sulfide are soluble. Exceptions are insoluble. Exceptions are hydroxide, these four hydroxide. Now you can use these solubility rules and predict whether ions in aqueous solution will react with each other to make a insoluble salt. Which of the following compounds is insoluble in water? Chlorides are soluble except lead, silver. Calcium nitrate. Nitrates are soluble, all nitrate. Acetates are, regardless of what is the cation, they are soluble. Calcium carbonate is insoluble. Therefore, this is the correct answer. None of them are correct. Insoluble salt is the carbonates are insoluble except group 1A and ammonia. First solubility rule. Therefore, A is the answer. Which of the following compound is soluble in water? If you look at this, we already said silver chloride is insoluble. Therefore, it is not the soluble salt. Silver bromide and silver bromide and iodide are insoluble. Acetate are soluble. Therefore, silver acetate is the only soluble salt. Anything with acetate is this C2H34, H3O2. That's the correct answer. Which of the sulfides are soluble in water? Sulfides are insoluble in water except group 1A. Potassium is group 1A. Therefore, this is the soluble sulfide. These are insoluble because only sulfide soluble in water is group 1A and ammonium sulfide. Answer is C. Which of the anions always form a soluble compound? We already talked about anions, nitrate and acetate. OH doesn't form always soluble. Sulfate has exception. Therefore, answer is A. Which of the following form always forms soluble compound? That is also A. Acetate is the other anion beside nitrate anion here. So therefore, answer is A in this case also. I'm going to look into predicting whether ions in are and few more questions. Examine the reaction taking place in the beaker in the image, where there's a precipitation reaction is taking place. Do you see the precipitation? These are the choices. A precipitation is forming, that's true. A metal being reduced, there's no redox reaction. No electrons are transferred. Metal being oxidized, that's redox. Precipitation reactions are redox reaction. Salt is not dissolving, salt is precipitating out. Answer is A. Examine the reaction taking place in the beaker in the image. Which of the following might be product being formed in the beaker? There are 4 choices. These are the only salts that's possible when you mix up 2 solutions in them together. This is not a salt. This is a cation. Therefore, choice is between these 2. Only insoluble salt shown here should be silver is the only insoluble salt. Silver chloride is insoluble. Potassium nitrate is a soluble salt according to solubility rules. B is the correct answer. We done talking about precipitation reaction. We gone over how to predict solubility rules. Use solubility rules to predict possibility of precipitate formation. When you mix up acid and a carbonate, a gas is formed. This is considered as acid-base reaction, except calcium carbonate produce carbon dioxide and water. carbonates produce carbon dioxide and water. This is a gas formation reaction. The question they ask him whether reaction is balanced. So you count the number of whether formula is correct, whether if it is balanced. Calcium nitrate, correct formula is this. This is correct here. These two are incorrect. Calcium nitrate is, calcium is 2 plus nitrate is 1 negative. Therefore, there should be 2 nitrates. Out of these two answers, if you look at this one is not balanced. There are 2 hydrogens here, only 1 hydrogen here. This reaction is balanced. 2 nitrates here, 2 nitrates, 1 calcium here. This is the balance equation for the gas formation reaction. There are reactions called gas formation reaction, like precipitate reaction. They drive reaction to the product side. So that reaction is balanced. D is the correct answer. The product of reaction of phosphoric acid, that's the acid, and the sodium magnesium hydrochloride, not sodium, magnesium hydroxide. Water is formed. Acid-base reaction, where acid and a hydroxy base produce water. Driving force is like precipitation formation, water formation is the driving force. So you have to look at these 4 equations and find out formulas are correct and the balancing is correct. This magnesium phosphate is wrong. Correct formula for magnesium phosphate is this. This is wrong also. This is the magnesium phosphate. This is incorrect also. Therefore, only correct reaction with correct formula and balancing is D. There are 6 hydrogens here. And 6 hydrogens here. They add up to 12 here. Therefore, hydrogen is balanced. If you look at the rest of the things, there are 2 phosphate groups, 2 phosphate groups. Therefore, oxygen also balanced. There are 6 oxygens here and 6 oxygen here. Therefore, balance equation is D. So we're going to talk about a little bit about gas formation reaction. Ion solution react with each other. One of the following things can happen. It can form an insoluble compound in water, precipitation reaction. That also can produce a gas that escape from the mixture, like the equation we balanced in the last slide, first equation, gas formation reaction. Carbon dioxide form. That drives the reaction to the product side. For example, this is sodium bicarbonate net ionic equation. Sodium ion is there. And the HCl, hydrogen, so it produces sodium carbon dioxide gas. Sodium chloride is formed. That is removed in the net ionic equation. So this is an example of a gas formation reaction. Sodium bicarbonate react with acid to produce gas. We're going to talk about acid bases in chapter 8 in detail. Now we finish the precipitation reaction. We mainly talked about precipitation reaction, acid-base reaction, gas formation reaction. The next reaction type is oxidation, reduction. This is also called redox, R-E-D-O-X, redox reaction. What takes place is for example, zinc react with copper 2+, transfers the electron, and zinc transferring after transferring 2 electrons become 2 positive, copper become neutral, 0 charge. So that's the electron transfer. Electron transfer reactions are called redox reaction. There's a definition about electron loss. Electron loss from an atom or ion is called loss of electron, oxidation. Reduction is gain of electrons. Zinc lose electron, it get oxidized. Copper gains electron, it get reduced. How you remember loss of electron is oxidation, gain of electron is reduction. This is the mnemonics. Leo is the Disney lion. That lion is called Leo. Leo stands for loss of electron is oxidation. SACE is just to keep the mnemonics. GER means gain of electron is reduction. Loss of electron is oxidation. Leo says this. So you have to remember loss of electron is oxidation, gain of electron is. When you're describing redox reaction, electron transfer take place. Now we also use the word oxidizing agent. Oxidizing agent is the substance that reduce. You only look at the product reactant side to figure out. You look at the reactant side of the redox reaction and find out which one is reduced, it is the oxidizing agent. If you found out which one is, that is oxidized. Which one is oxidized, that's the reducing agent. There's a mistake here. If you look at this one is the oxidized. This one is copper 2+ is reduced. Therefore, what is reduced is oxidizing agent. It helps zinc to get oxide. Agent is helping somebody else. Zinc is oxidized, is the reducing agent. Therefore, these are kind of inverse relationship. Species that is reduced is the oxidizing agent. Species, you only look at the left side of the redox reaction. In redox reaction, we don't look at product side. Because if you mix up these two, you're going to get confused. Only you're going to stick to the left side and predict what is oxidized, what is reduced. Oxidizing agent and reducing agent. You can figure that out. Let's answer some question. Which of the following definition of oxidation is generally most useful when dealing with ionic material that contain metal ions? Oxidation of its gear, we never talk about it yet. For ionic material, that's not true. There's a clear loss of electron that's the correct answer. Ions exchange directly electrons. So other choices are oxidation is loss of hydrogen. We never talk about it yet. None of these. That's not, only this one is correct. B is the correct answer. Loss of electrons, we said oxidation. Reduction is gain of electron. Leo says the. Which is the reduction in which is reduced in the reaction? In here, lead is converted to lead 2 plus. This gives 2 electrons to silver. Silver becomes silver 0. There's no charge. Therefore, reduction is taking place. Gain of electrons is on silver ions. So there are 2 silver ions, but you only say what species that reduces silver plus. We only looking at reactant side. Therefore, this is the correct answer. B is the correct answer. What species is oxidizing agent? Now you have to look for reduced substance that is reduced. Is the oxidizing agent. So this one is reduced. Therefore, it is also the oxidizing agent, opposite of reduced. So therefore, answer is still B for this question, oxidizing agent. What species is a reducing agent? We are in reducing agent. That is we are looking for oxidizing agent. So this is oxidized. Therefore, it is a reducing agent. Therefore, answer is A. Now we are going to talk a little more about oxidation reduction reaction. You have zinc metal here and solution of copper sulfate. You place a piece of zinc metal in copper sulfate solution here and let them react. After a few minutes, you begin to see copper is deposited on the zinc plate. As copper is deposited, the green color of the solution turns lighter. Green is because there are copper ions. Copper ions have green color. Copper 2 is variable charge cation. So this is electron transfer taking place directly between copper sulfate and zinc solution, zinc metal. We can create a galvanic cell or battery by isolating these 2 metals, zinc and copper. This we talked about. Zinc metal dissolves. zinc goes into the zinc 2 plus. Copper is 2 plus, goes to copper. That's the black material found in here. So this reaction takes place directly. How are we going to get an electrical current out of these redox reaction? So you have to look into detail before we come up with a device called galvanic cell. This is the same reaction. Zinc is placed in copper sulfate. Zinc has no charge. Copper sulfate is 2 plus charged, shown right here. Zinc goes to 0, become 2 plus. That is oxidation, loss of electrons. Copper 2 plus goes to copper 0. That's a reduction. These charges on the metal atoms are also called oxidation number of the metals. Oxidation number of 0 is zinc metal is 0. Oxidation number is 0. It changed to plus 2. Oxidation number increased from 0 to plus 2 here. I'm sorry, this is wrong. From decrease from plus 2 to 0. In this case, increase from 0 to plus 2. Therefore, oxidation is increasing oxidation number. Reduction is decreasing oxidation number. These ideas are used in creating 2 electrodes to get a galvanic cell. This is the oxidation half reaction that comes out of this part. The reduction half reaction is coming out copper going to copper sulfate and copper. Copper gains 2 electrons. This is called reduction half reaction. A galvanic cell isolates these 2 electrons, reduction half reaction and oxidation half reaction. In a galvanic cell, where the oxidation takes place is called anode. Anode is considered anions, positively charged N. Cathode is where the cations comes, therefore cations get attracted to cathode. The idea is where the oxidation takes place is the anode, where the reduction takes place is the cathode. So let me show you voltaic cell that separates out the 2 electrodes, reduction half reaction and the oxidation half reaction, by separating out zinc and copper electrodes. This is zinc electrode. This is copper electrode. You have, for example, zinc sulfate here, copper sulfate here. These are the 2 electrodes. Anode, where the oxidation is taking place. That's the cathode. We normally write down anode on the left side. Right side, we write down cathode. Electrons are lost from zinc. It passes through, lights up the bulb here, and come back and goes through solution, electron flow, and pass through the Soul bridge. Soul bridge is a device that completes the electrical circuit to run the current. So that's how we create a electrochemical cell, or electrochemical cell is a battery. There are all kinds of alkaline batteries similar to this one, which has two electrodes, cathode and anode. Positive end is the anode, negative end is the cathode. The cations goes to cathode, anions goes to anode. Those are the ideas using electrochemical cell. Let's talk about a galvanic cell where the two electrodes are separated. Which is the cathode in the galvanic cell? This is the cathode, this left half, which is the silver. Though silver is this one is the correct answer. This is the anode. Now these are about solutions. Solutions have nothing to do with direct electron transfer. They continue through the solution, but they are not cathode or anode. Cathode is a metal piece to one of the two metal pieces. Left side, you find the cathode. Anode is found on the left side. Anode is left side. That's the anode. That's the cathode. Cathode is the solid silver electrode, which is this. So in this reaction, two electrons are transferred. In an electrochemical cell or a galvanic cell, anode is electrode where oxidation takes place. I talked about that in the previous slide. That's the correct answer. The material used to connect the two half reaction cells to each other. This Soul bridge is the material that connects two half cells. It is not the anode. It is just a connection only. Always use up, anode is used up before cathode. It depends on relative amount of, if you have a large piece of zinc, it will never be used up. Therefore, this is nothing to do with cathode, the anode. It has to be a metal, either zinc or silver. Therefore, only choice is A. In this electrochemical cell or galvanic cell, reduction place half reaction is where the oxidation is placed. I talked about it. Reduction half reaction is where the reduction half reaction is the cathode. Reduction is this, gain of electrons. This is loss of electron. That's not. These don't have electrons in node. Therefore, correct answer is reduction is gain of electron. That should be the cathode. Out of zinc and copper, this is the oxidation half reaction. They are asking for reduction. That's the correct answer. Answer is A. Now we're going to change our topic a little bit. There are chemical reactions which are called combustion, where carbon is burned to produce carbon dioxide. Hydrocarbons are burned to methane, burned with oxygen to produce water and carbon dioxide. These reactions are redox reactions. Their electron transfer take place directly. They are not metal ions. They are not ionic solution. Therefore, hard to produce the galvanic cell. But it is possible to produce, but it's hard. Oxidation take place, but there's no clear loss of electrons. But reduction we define as gain of electrons. To apply idea about oxidation reduction to combustion reaction, we have to come up with another way to apply this idea to this type of reaction. When you look at this reaction, combustion reaction, produce carbon dioxide and water. In this case, carbon gains oxygen. Carbon is turned into gain of oxygen. Hydrogen gains, oxygen gains in here, hydrogen. There are hydrogens with the oxygen. Carbon now with the oxygen. Carbon gains oxygen. Oxygen gains hydrogen. So oxidation is, there's another way to define oxygen for combustion reactions or organic reactions. Gain of oxygen or loss of hydrogen. These are two equal ways to say redox reaction taking place in organic redox reaction. Respiration applies to, this idea applies to respiration also. Gain of oxygen or loss of hydrogen. Reduction is loss of oxygen or gain of hydrogen. So these two ideas are used to define combustion reaction. Let's look at some more examples. Therefore, alternative definition for combustion of methane. Gain of oxygen is oxidation. Loss of hydrogen is also possible, oxidation definition. Reduction is loss of opposite of whatever here on the top. Gain here, loss here. So now it is easy to remember. Gain of oxygen is oxidation or loss of hydrogen is oxidation. Reduction is loss of oxygen or gain of hydrogen. For example, if you look at CHO, in this, it gains oxygen. This is oxidized. Oxidized. Gain of oxygen. It lost hydrogen. That is definition of oxidation. Oxygen gains hydrogen. So it is reduced. Therefore, we can also use the idea, whichever oxidizes is the opposite agent, reducing agent. Reducing agent is CHO, oxidizing agent is, which is reduced, oxidizing agent is oxygen. Which of the following is oxidation, according to our new definition? Oxidation is loss of electrons, loss of hydrogen, or gain of oxygen. All these three definitions covers oxidation. Therefore, all of these are now defines the oxidation of any redox reaction. Which of the following is the reduction? Reduction is gain of electrons. That's true. Loss of hydrogen is oxidation. Gain of oxygen is oxidation. Therefore, only answer is A. Following is the reduction. If you look at this equation, formaldehyde with oxygen, this compound gains oxygen. Therefore, this is oxidized. Therefore, this is reduced. Oxidized is first compound in the reaction. A is the correct answer. On the next problem, which is reduced, oxygen is the one being reduced. You only look at the left side. We already talked about, we only look at the left side to figure out oxidation or reduction. Therefore, answer is A, which is oxygen, not this one. This is oxidized. This is the reduced. B is the correct answer. Few more problems. Which of the following are the products incomplete combustion of hydrocarbon, methane, or propane? Complete combustion produces carbon dioxide plus water. Incomplete means carbon monoxide is produced before everything is converted to. If you first burn carbon, it produces carbon monoxide. Then with more oxygen, it will completely burn carbon monoxide. Like if you run a car in a closed garage, it produces carbon monoxide because oxygen is depleted. So incomplete combustion products are this. This is not water. Therefore, this is complete combustion. Therefore, this is the correct answer. A is the correct answer. Which of the following is true of respiration? It is the conversion of iron to iron oxide. That's nothing to do with respiration. Iron oxide is Fe2O3. That's not involved in respiration. Conversion of colored compounds to colorless compound. There's nothing to do with respiration. Is not changing color. It's just glucose burning in oxygen to produce carbon dioxide and water. It is the production of energy in human and animals biological system. That is the correct definition of true of respiration. It is the generation of electricity in a voltaic cell. We don't produce electricity in voltaic cell using glucose and oxygen. So that's not correct. That's the correct answer is C. Which of the following is true for bleach? Anything that bleaches is the reducing agent. Bleachers are oxidizing agents. If you use chlorine, chlorine gets oxidized to chloride. It gains electrons. Therefore, acid something else to get oxidized. There's a oxidizing agent. It gets reduced. Both reducing agent and oxidizing agent. No, oxidizing agent is the correct answer. Neither, that's not correct either. Answer is B, oxidizing agent. So it oxidized the material, dirt, or on clothes or countertops when you use chlorine as a bleaching agent, which is reduced in the reaction. This is oxidized. It goes to lead. This is going to silver. That reduced. So B is the correct answer. We gone over some of that. Which is oxidized? That's a look like the same problem. A, oxidizing agent. This is oxidized. Therefore, oxidizing agent is which is reduced. B is the correct answer. You only look at it. Look at the reactant side. Which is the reducing agent? I think I gone over this material. Reducing agent is lead. I'm going to talk about stoichiometry in the next class period. So we will meet at 10 o'clock on Thursday, next Thursday. All right. Do you guys have any questions?
No, sir.
All right. Read the material and go back to the Zoom meeting if you didn't understand anything. Just try to understand the concept and answer questions. All right. See you guys in 10 o'clock next Thursday, 10 a.m. Okay?